I hope you are ready for our next example. I have 14 students in my class and I want them to line up and I want to know in how many ways they can make this line. So, I don't know, like just as I give an example, let's say I have Luisa in the first place and then it comes Ali and then it comes Yuli and so on. And then I'm going to have a line with the 14 of you. Yeah, don't get offended if I didn't mention your name, huh? I'm not gonna mention the 14. So how many ways can we do this? So we're gonna look at the first spot and we're gonna think how many ways can we fill this first spot? Well, there are 14 of you, so there are gonna be 14 ways for that spot. Once we pick someone for that spot, for the next one, we only have 13 options. If I say that it was Luisa that was standing in the first spot, then, well, I cannot put Luisa again in the second one because there are not two of them. So we're going to have 13 options for the second one, and then we're going to have 12, and this keeps going like this until, well, the last one is going to be the last one, the one that is left, and there is only one option for that. Notice that this is actually an application of the multiplication principle. The first event can happen in 14 ways, the second one can happen in 13 ways, the third one in 12 ways, and so on. And then if the question is in how many ways they can happen, all the events one after the other, well, the answer is that we need to multiply this 14 times 13 times 12 all the way up to times 1. So, well, what is this? This is going to be a huge number, but I hope you're fine with the reasoning that this is how we find this huge number. Luckily, there is a shortcut to write this. This is called a permutation. This is actually a permutation of 14 elements. Yes, I'm calling my students elements. That's okay. It's almost 9 p.m. I can do that. And when we are trying to do this, we need to multiply 14 times 13 times 12, blah, blah, blah. But just, sorry, I should have mentioned this. Permutation is just a way of saying a change of order. So we are changing the order in 14 possible elements. And there is a very convenient notation to write this, and it's 14 exclamation mark. This exclamation mark over here, in mathematics, we call it factorial. So instead of writing 14 times 13 times 12, blah, 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 times 1, we just write 14 factorial to mean exactly that. And about this notation, let me add two things. First of all, we agree by definition that 0 factorial is exactly 1. Well, there's no way of doing the same multiplication process when we start with 0, so we just do 0 factorial, and this is equal to 1. Let me write a few more. Well, 1 factorial is equal to 1, 2 factorial is equal to 2 because it's 2 times 1, 3 factorial is equal to 6 because it's 3 times 2 times 1, 4 factorial is equal to 24, and then 5 factorial is 120, and then I don't remember them by heart anymore, and that's okay because you can find these very quickly using your calculator. So go to your calculator. Let's say we want to find 6 factorial, so we want to know how much is 6 times 5 times 4 times 3 and so on. So 6, and then come over here next to the letter G. This open up a few options, and the second one is exclamation mark. So 6 exclamation mark, and yeah, you can see it there. Let me move this. That's 720. So let's find 14 factorial. Okay, that's that huge number that I'm gonna copy here and put it as the result. There you go. That's our 14 factorial and how many ways my 14 students can line up. And the number is so huge I copy pasted, but I have no intentions of reading it out loud. Let me change this problem a little bit. Now I want 4 of my 14 students to line up. In how many ways can we do this? So let's go back at thinking and could be how many options we have for the first spot in the line. We're going to have 14 options. For the second spot in the line, we're going to have 13. For the next one, we're going to have 12. I'm already multiplying those options because I'm applying the fundamental principle of counting. And then for the fourth one, I'm going to have 11 options. And that's it. So I need to find what is 14 times 13 times 12 times 11. And well, I can just go to my calculator and find that 14 times 13 times 12 times 11. But it would be convenient to notice that actually we can imagine that this is in fact, let me erase this here. This is in fact a quotient of factorials, because I could keep multiplying times 10 times blah 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 all the way times 2 times 1. So here I'm multiplying everything by 10 factorial, and then I can at the same time divide all of these by 10 times 9 times blah 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 all the way times 2 times 1. So 10 factorial again. So we agree that I multiply and divide by the same number, so I didn't change my number. But why did I do that? Because now we can write this as, if you see in the numerator, what we have in fact is 14 factorial, and in the denominator we have 10 factorial. But what is this 10 factorial? Well, what we have here is 14 factorial divided 14 minus 4 factorial. So if we pick only 4 of the 14 students, the 4 is reflected in the denominator here with this 14 minus 4, and then we have the 14 factorial in the numerator. Okay, I made a little bit of space over here to be able to keep my reasoning. What we have over here that we can write very conveniently as 14 factorial or 10 factorial and find it in the calculator. This has a name. These are permutations. Yeah, well, they are permutations because we are arranging the order of 14 elements, and we are taking 4 of them. So we are taking 4 at a time of them, and this we can write it as permutation 14 4. And good news again, we can find the result of this in our calculator. Now we could of course write just over here, we could just go ahead and write 14 factorial divided by 10 factorial. That will do it, but we can be more specific if we want. We can go here to menu, and then in probability we have here, oh look, there is one that is called factorial. You could use that too. Then there is this that is called permutations, and then this NPR, it's well, different notation that I wrote before, I'll add it in a second, is permutations of n object taken r at a time. So in my case, my r objects are my 14 students, and I'm taking 4 at a time. So I need to write inside the brackets 14, 4, and of course we get the same with this way of calculating. So going back to our picture over here, let me write this as 14p4. This is just notation.